Good morning, sir. This is B. Balaji from Triple E Department, A section. Today, I am going to discuss about irrotational vector. Introduction to irrotational vector. An irrotational vector field is one in which the curl of the vector field is 0. This means that the vector field is conservative and can be expressed as the gradient of a scalar function. And irrational vector fields are often used in fluid dynamics and electromagnetism to describe the flow of fluids or electric fields. Irrational and solenoidal vector field. Properties of irrational vectors. In an irrational vector field, the path taken by a particle is independent of the path itself. Stokes' theorem can be applied to irrotational vector fields, relating the line integral of the vector field to the surface integral of its curl. Irrational vector fields satisfy the Laplace equation, which is a second order partial differential equation that describes the field's behavior in space. And the formula is f bar equals to x square plus xy square into I plus y square plus x square y into z. Now we discuss about direction derivative of a scalar point function. Introduction to direction derivative of a scalar point function. The direction derivative of a scalar point function measures the rate of change of function in a specific direction at a given point. It provides valuable information about how the function behaves along a partial direction from the point in question. By calculating the direction derivative, we can understand how the function varies with respect to a chosen vector differentiation point function. First point function is scalar point function. The scalar point function is divided into 2, f into x square x f x y or f x y z, and vector as well as vector point function also divided as f bar x y and f bar f x y z. Now the calculating direction derivative. To calculate the direction derivative of a scalar point function, we use the gradient of the function along the specified direction. The direction derivative is obtained by taking the dot product of the gradient of the function and the unit vector representing the chosen direction. Mathematically, the direction derivative dv f into f xy at a point xy in the direction of a vector unit vector v equals to av is given by derivative f xy equals to delta f xy dot v equals to af x into xy plus b f y into xy, where here the question is show that curl r power n dot r bar equals to 0. Here the solution is, we know that r bar equals to xi bar plus yj bar plus zk bar. That implies r power n into r bar equals to I power n into xi bar plus yj bar plus zk bar. That implies r power n dot r power bar that equals to x r power n into I bar plus y r power n into j bar plus z r power n into k bar. That implies curl into r power n r bar equals to delta cross r power n into r bar. That implies delta equals to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. That implies delta into r power n into r bar equals to mod of I bar j bar k bar dou by dou x dou by dou y dou by dou z x r power n y r power n z r power n. That implies I bar into dou z r power n by dou y minus dou y r power n by dou z minus j bar into dou z r power n by dou x minus dou x power x r power n by dou z plus k into dou y r power n by dou x minus dou x power r x r power n by dou y. That implies dou into r power n dot r bar equals to dou I bar into zn r power n minus 1 dou r by dou y minus y n r power n minus 1 dou r by dou z minus j bar into zn r n minus 1 dou r by dou x by minus x power x n r power n minus 1 dou r by dou z plus k bar y k bar into y n r n power n minus 1 into dou r by dou x minus x n r power n minus 1 into dou r by dou z. That implies n r power n minus 1 into I into z r dou r by dou y minus y dou r by dou z. Dou r by dou x equals to x by r, dou x by dou y equals to y by r, dou r by dou z equals to z by r. That implies n r power n minus 1 into I bar into y z by r minus y z by r minus j bar into zx by r minus zx k bar into yx by r minus xy by r. That implies dou x into r power n minus r bar equals to 0. Curl r power n dot r bar equals to 0. Hence proved. And thank you very much, sir.